Hello everyone. I would just like to do an example of the ambiguous case when using the law of sines. So here I'm given three pieces of information about a triangle. I have two side lengths and I want the angles. Based on the notation, I know that this angle A is the angle that is opposite the side length A of 25 here. Now, because it's the side-side angle sort of situation, I do need to check to see if a triangle exists, if there are two triangles, or if there's just the one triangle. So if I compare A and B, I can see that A is less than B, and I also see here that A is an acute angle, which means we have one of four possibilities. To determine what possibility is going to be, we also need to compare A to the potential height of the triangle. So let me just start with a sketch. Let's say that this is angle A, and that is about 43 degrees, so something like this. So across from here would be the third side of our triangle, which is going to be 25, but we don't know exactly what that's going to look like quite yet. But to determine that, we need to compare it to the height, so we can draw that in. So that would be a little right triangle here, and that's H. And then let's say that this is side length B, so this is 28. So to find the height of the triangle, we can easily do that using sine. So the sine of 43 is equal to H, or 28. So H is equal to 28 times the sine of 43, which is a value of about, if I type that into the calculator, about 19.1. So based on our information, we have A is less than B, but we do have A is greater than H. So because of that, our triangle actually has two possibilities. We have one where that side of 25 comes in like this and creates a triangle that way, or our other possibility is that side length 25 goes this way, and that's our third side. This would be angle B, or that would be angle B, and then this last one up here, let's call that one C. So two possibilities here. Let's find out the rest of the information for each triangle, for each possibility. To do that, we can start by using the law of sines. So the sine of an angle divided by the side across from that, and the sine of another angle, the side across from that one. So let's start by finding angle B. So we're going to be finding either this angle here, which looks like it's going to be the obtuse one, or the second possibility for angle B, which is going to be acute. So plugging in what we know, the sine of angle A is 43, and across from that we know it's going to end up being 25. We are going to solve for angle B, but the side length across from that is the 28. Now, because I am going to find an angle measure, I do know that I am going to end up using the inverse sine at some point. Before we do that, we need to isolate the sine of B. I'm just going to do that by multiplying both sides by 28. So 28 times the sine of 43, over 25. And then to find angle B, we need to undo the sine, and that's where taking the inverse comes in. So using the inverse sine of both sides of my equation, we're going to take the inverse sine of this entire fraction. So it's a little messy, but typing that in our calculator is going to give us one of the possibilities for angle B. And one thing I mentioned before, you just need to be careful on how you enter this in. Make sure you use your parentheses. Make sure you get the calculator to do the order operations correctly. So the inverse sine 28 times the sine of 43, and then close the parenthesis there, and then we'll divide that by 25. So one possibility is angle B is about 49.8 degrees. So that is an acute angle, so that would be the bigger triangle here, where side length A is coming out to the outside. So this 49.8. Now our second possibility, this side length is also 25, and it is actually just reflected over the height of our triangle. So this is essentially an isosceles triangle, which means that this angle is also 49.8. So on the inside of the triangle, this is just the supplement to the 49.8. So to find our second possibility, let's just take 180 and subtract the 49.8. So we get about 130.2. So those are our two possibilities for angle B. Because we have two possibilities for angle B, we have two possibilities for angle C, both of which can be found using the triangle sum theorem. So our first one, the measure of angle C, 180 minus 43 for angle A, and then we'll subtract the 49.8 for angle B. So that ends up being about 87.2 degrees, or do 180 minus 43 for angle A again, and we'll subtract our other possibility for angle B, 130.2. Which gives me 6.8 degrees. Okay. Now that I have my angle measures, I can find my last side. So for that, I also have two possibilities. When angle C is our larger one of 87.2, that's going to be this entire length from A to B out here. And when angle C is real small, 6.8, that's going to give me my length from A to B here. For both cases, we can do that using the law of sines again. Okay, so let's start with the larger angle, 87.2. So we'll do the sine of 87.2 and the side across from that, which we'll call C. And I'm going to set that equal to the sine of another angle on the side across from that. Now, when I'm doing this, I do want to be sure that I'm using my two my possibilities here. So I want to use my angles for B and then the side length of the 28. So the 87.2, that one I got from using when angle B was 49.8. So the sine of 49.8, and then we'll put that over the side length of 28. Again, this is a proportion, so we can use our cross product, and we end up with C is equal to 28 times the sine of 87.2 divided by the sine of 49.8. So that is one possibility for side length of AB. And if we type that in, let's see, 28 times the sine of 87.2 divided by the sine of 49.8. Watch my parentheses there. We get 36.6. Okay, so So that one checks out. The 87.2, that did end up being the largest of the three angles there. So that means our last side length should be larger than the 28. So that looks good. Now for our last possibility, we're going to use when angle C is 6.8. And now I want to match this up with my other possibility for B. So now we're using the larger angle B, which is 130.2. And then that will still go over the side length of 28. Cross product here. Expression is going to look similar, so we end up with 28 times the sine of 6.8 divided by the sine of 130.2. So then our other possibility for side length AB, 28 sine of 6.8 divided by the sine of 130.2. So that is about 4.3. Which again, that checks out. 6.8 is a really small angle, so it makes sense that the side across from that should be a really small side. Okay, so putting that all together, we have our two possibilities for triangles. Our first possibility, measure of angle B was about 49.8. The measure of angle C was about 87.2. And then our last side length was about 36.6. Second possibility for the three missing pieces, the measure of angle B is about 130.2. The measure of angle C is about 6.8. And then the last side was about 4.3. Okay. Hopefully that looks good. If you have any questions, let me know, and I'll be in touch soon.